Hey everyone, this is episode 2 of making my game. So we're making a sand city game, which is where you're a person and you're going to be running around a beach and you're going to be making sand castles, and then the waves are going to be washing the sand castles away. Um, so right now we're just working on the very basics of Unity right now. We're just getting movement down. So we're trying to figure out how to move a character around even just a flat piece of land. But before I do any of that, I'm going to test out my settings right quick. So if you don't mind, just give me a little bit. I am going to play around with my bit rate. So right now I'm at 1 megabit. Let's try to go to maybe like 1.5. Just looking for something pretty consistent without any like major frame droppage. So I hit apply. Looks like it's going. CPU's very low, so it's encoding just fine. Yeah, it's dropping some, I see. I'll just keep it at a meg, and hopefully it will work out just fine. Okay, so let's get to it. So I will just go ahead and delete that. So the stuff I missed last time. So I was talking about when you actually clicked on the terrain and it created an array to figure out where you clicked on in 3D. I mentioned this, that if statement where it says if input, let me just pull it up. Here we go. If this one, if input.get button down fire 1. So I was going to say I was going to explain this, but I didn't explain it. So let me explain it right quick. If I go to Unity. Oh, and the other thing I updated in Unity was I'm actually capturing the whole monitor now. So like if I click on that, you actually see the menus I'm going in. Last time I didn't have that set up, so you didn't see the menus. Oh, actually, and let me do one last thing. I'm going to post on Facebook that I'm streaming now, because I didn't do that last time, and it'd be good to see if anyone wants to watch. I don't remember how to post on Facebook. Oh, it's on my mind. Live stream. See, start it. So live stream started. I guess I should put a post to the Twitch channel, which is ETdoFresh. Cool. I guess I gotta change that icon. So I should put a post to the Twitch channel, and I just realized I want to mute that. Alright, posting. And closing. And closing this too, because I don't need that to waste my bandwidth. Alright. So yes, back to what I was talking about. So this Fire 1. Unity has a predefined set of input commands. So if I look under Edit, Project Settings, Input, you'll see on the, oh, well, you won't see. Let me get rid of some of this stuff, like the notepad. Alright, so here on the right hand side you'll see the input manager. If I click here on the axis, you have all the different commands that are built into Unity, and this is what's built in by default. So if I look at horizontal, the command name is horizontal, and then it gives you like a negative and a positive button. So if you hit the left, it'll like return a value of -1. If you hit a right, it returns a value of 1. And if you have like one of those Xbox controllers, it will, like, if you just push the nib a little bit, it will only go like 0.5, or, you know, however much you're pushing the axis. So there's a horizontal axis and a vertical axis on this. So the horizontal is left and right, and if you just hit like a key on the keyboard, it's just going to go full force left, full force right. Vertical, same thing except up and down. And you can see just like the WASD keys or the up and down arrows, those are all just alternate keys. Cool. Fire 1, so that's the left control or mouse 0. So I use this, so I said if this button was pressed down, or if this command is pressed down, whether it's the left control on the keyboard or mouse 0, which is your left mouse button, go ahead and launch that command. So that's Fire 1. And I just wanted to mention that because I know I skipped it last time and I said I was going to explain it, and so that is the explanation. So that is done. Alright, so what are we going to talk about this time? We're going to talk about, yes, more about movements. I'm just going to just briefly introduce the animation movement and the rigid body movement so that we can finally put it all together. So what I'm going to do is I am going to open my scene. It's under here, scene 00. And I'll pop this notepad back off so we can see what we're doing here. Alright, so this is where we left off last time. We have just this cube at the ground. It's just a height of 1, but it is 30 by 30. So if I click that here in the scene view, that's the 30 by 30 by 1, and we moved it down 0.5 because the center of the cube is, in a 111 cube, is 0.5, 0.5, 0.5. So if you put that down, the top of the cube is now on the ground. So that's how that works. Alright, so we got the ground, we got an obstacle. If I click navigation, we'll see the blue area, the navigation mesh. Like I mentioned before, unless you have the pro version, you can't get up on top of the sphere. You'd have to use an off mesh link. But we're using the free version, and so it's just an obstacle in the way. So if I hit play, we can see that my player is a nav mesh agent. It doesn't collide with the boxes, but it moves. So nav mesh agent is controlling the movement. So let's stop this and let's see where we want to go from here. Okay, I guess I'll go rigid body first, and so that we can just understand how the rigid body works. So just like the cubes, I'm going to make the player a rigid body. So I'm going to just disable the nav mesh. So if I do that, oh, and the nav mesh movement script. If I do that, if I click anything, nothing's happening now. I just disabled all the controls that we built so far for this guy. But go ahead and enable this capsule collider again, because this is what's going to tell the physics objects what is this object. And so right now it's just nothing. There's no movement engine to this at all. So if I put physics rigid body, it's now a physical object. So if I lifted him up a little bit and I hit play, he'll fall along with the cubes just like he was just kind of dead weight like everything else. And notice, I don't know if you can notice, but let's see if I shift F or double click it. Yeah, so he's rolling around, and what I do want you to notice is that it's not really colliding with the ground, his eyeballs, because I took out that box collider. So he's straight up a cylinder, and he's just rolling, and he will roll either until friction stops him, or he'll just roll right off this edge, which he probably will. So I'll just let him do it because I'm like seeing it. Alright. So yeah, so he's dead weight. That's when we start messing with this right hand side, the rigid body components. So this rigid body components here on the right hand side, I'm going to leave most of the default settings because I'm not going to go too crazy explaining everything, but I do want to show you a few things. Here's some constraints. So if you want physics to react every other way except a certain dimension or a certain rotation, you can do that through these constraints. So if I do Y, physics will take place on this object, but he won't fall down to the ground. Like gravity won't have any up and down effect on him. So he's just kind of floating in the air, and he got hit by something, so he's being floated a certain direction, but there's no friction, so he's not touching the ground, and he's going to be floating that way forever. And then if I uncheck it, bam, he falls to the ground. Alright, so why am I showing you all of this? Well, on a top-down shooter or top-down anything, most of the times you want your guys to be standing straight up. So you don't want the guy to like fall over to the left, to the right, back, forth. So we usually constrain the rotation, everything but, oh man, I think the X and the Z you constrain, but you don't constrain the Y. So he can only turn around like this, like without falling over. So to prove that, first I'll just show you here as a rotation. It would just be rotating on this green axis. This Y is green, this is green. So if I like rotate it, he can only rotate this way. He wouldn't be able to fall over like that or he wouldn't be able to go back and forth like that. So I'm going to constrain the X and the Z. So if I do that and play, he's going to fall down, but he's going to like land on his feet and he won't move. Like, that's all he's going to do. So great. He's now constrained. He won't rotate left or right like that. He can only rotate around the center of his body and the y-axis. So I hope that makes sense. That just means he can turn clockwise and counterclockwise if you're looking top down. So kind of like what our NavMesh agent is doing, except just a little bit different. So what do I want from this? Let's, I guess, combine this and the NavMesh agent, because the NavMesh agent is going to tell us, hey, I really want to be going this velocity, but instead of making this object move, we're going to just tell the rigid body to move, and if we're telling the rigid body to move, the rigid body will now move the object in that direction. So here is going to be the very rough way that we're going to do it. I'm going to go ahead and create a new script. We're going to call this NavMesh rigid body movement. So basically we're using both engines to kind of do the same action. So okay, reload all, it asks me that sometimes, and I'm just going to copy the code that we did for the NavMesh movement, just so we have a nice starting point. Alright, so we have the NavMesh rigid body movement class, we have a variable NavMesh agent, and we need to grab one more component, and that's going to be the rigid body. So rigid body equals get component rigid body, open close parentheses. So now we have the rigid body, but we don't actually have a field for it. So bam, we put it on the top. So now we have a NavMesh agent and a rigid body. If you take out the word private, it's just the same things, because the default way it does it is going to be private. I'm going to delete this. This was where we got the kind of the camera rays, but that's how we did it. Alright. So we have the rigid body and we have the NavMesh. Alright, so last time I showed you how to break NavMesh agent, so I'm going to do that again. Just into start, which runs one time when you create the object. NavMesh agent update position equals false, and NavMesh agent update rotation equals false. Alright, so we got that. So NavMesh agent won't actually control the actual object. It'll control itself as a component, but it won't control the game object it's attached to. So if you don't know what I'm talking about, let's visualize it. If we go to the player, I'm going to go ahead and re-enable NavMesh agent. I'm going to go ahead and just remove this NavMesh movement script so we're not confused. And we're going to go ahead and put the NavMesh rigid body movement script back on. Okay, so you remember if you click somewhere, the guy's going to try to go there. So if I hit play, I click somewhere, he's not doing anything. But if I go a little deeper, I think if I open up the NavMesh agent, oh, you see there's this like cylinder that's somewhere else, and if I click places, that cylinder is going to keep moving. So that's the NavMesh movement engine that's still operating even though I told NavMesh agent not to move my game object. So the game object's like, I'm sticking where I am, but NavMesh agent's going to move wherever he wants to go. So but there's really just like one or two properties I want from this NavMesh agent. So if I click on navigation, we can kind of get a better feel for everything. I'll go top view. Let's do isometric just so it has that like nice parallel view of the world. And so if I click around, you can see that light blue arrow showing up. So that light blue arrow is really what I want. That is how fast I want to go. And I don't know. It might be taking in consideration how fast, because I see that like blue arrow kind of shrinking at the end. So it might even be taking into account deceleration, which is great, because sometimes that can be kind of hard to compute. So I'm glad. So what's the problem here? First problem is the NavMesh agent is kind of free for all. So even if I got another movement engine to do something, if like the rigid body movement goes forward and the NavMesh agent goes kind of like at a 10-degree angle, they won't be matched, it won't be synced. So we're going to have to make sure that the NavMesh agent is always in sync with the actual game object. So I'm going to do that first. So how do we do that? We're going to go back to the script that is here. And here is the script. So like I said, the update just runs continuously until the object's either destroyed or disabled, or the component itself is disabled, which the script itself is a component. Okay, I'll be quiet. Alright, NavMesh agent dot next position is the that little green cylinder, and I believe it's a vector 3, so I should be able just to say, hey, take my position. I'll put it at the end of the loop. Not that it makes much difference, I think, in this context, but alright, so at the end of the script we have NavMesh agent next position is equal to my current position, to the game object's current position. So if I save that, look in Unity and wait for it to load again. Yeah, if you modify a script while the game is playing, it will load, but sometimes the behavior might be a little unpredictable, so I like to just restart the game every time I make a change to the script. But if you know exactly what you're doing, that's a great tool. So okay, if I click around, now we see that that arrow, I mean that the cylinder is not moving away from the player, and that the player is just getting the information straight from the NavMesh, but not really doing anything about it, but at least he has the information and we know exactly where the NavMesh agent's computing from. I don't know a much better way to do this, but that's how I kind of worked around it for now until I find some better code or a better method. So okay, now we get the NavMesh agent. Now we're going to tell the rigid body to do something with the NavMesh agent's information. So I'm going to show you the very hacky way first, just so we can kind of get started right away. I hope this is right. We're going to take the rigid body velocity and we're just going to make it equal to the NavMesh body velocity. So this is basically NavMesh controlling your acceleration and your movement, but rigid body strictly adhering to that velocity and movement. So if I hit play, oh yeah, and you might want to disable the Y, because NavMesh agent will always have a 0 velocity movement. So if you try to say, NavMesh is saying don't move in the Y direction, and then you have physics, rigid body, gravity saying you're getting pushed down by gravity, they'll start colliding. So you'll see that when I hit play, the rigid body's like, I'm falling slowly because NavMesh agent's telling me not to move downwards. So that's why we got that kind of really slow moving guy downwards. So you're having conflicting movement engines already just doing this, combating each other. So what I'm going to do is I am going to just, what's the best way to do this? I'm not going to mess with the, I'm trying to think of the best way, I'm sorry. Alright, so I'm going to go vector 3, non Y. This is too much work. This is the best way I'm going to do it. I'm just make a new vector right here. New vector 3. The rigid body's new velocity is going to be the NavMesh agent's velocity's x direction. The rigid body itself's old or new or existing y velocity, and then NavMesh agent.velocity.c. So now, just here, x and z are being controlled by the NavMesh, y is being controlled by the rigid body. So, and this is just a really hacky way to do it. I know in my past presentation I said that we're going to use the add force command, and don't worry, we will. I'm just trying to get this working first iteration. Alright, so he's on the ground, hit a button. Okay, now he's even reacting with the boxes, which is awesome. So Y is not being affected, but X and Z are. So you can obviously see that. But rotation's not being handled very well because we didn't put any code for rotation. So basically, it's going to keep spinning. But there is a drag on it. So if I click on player, look in the inspector, there's a 0.05 drag. So that basically means that every iteration it's going to subtract that much torque, I guess, away from the physics. So in any given amount of time, even if you're spinning infinitely fast, well, not infinitely fast, but really fast, and you let an infinite time pass, it will eventually stop somewhere. So that's what drag does. So like if I really set drag to like 1, you'll see that he stops rotating, and basically it's a higher friction and drag, and just a drag, just the angle. So anyway, so we got our nav mesh agent, and a rigid body connected to it, so that's nice. But yeah, when you hit stuff, he just rotates out of control. And I could try to make the rigid body use torque to like figure out where he needs to turn, but I'm kind of lazy. So what I'm going to do is I'm going to just let the nav mesh agent for now take over control of rotation. So because I did that, nav mesh agent will take control of the rotation, and so what is happening? So nav mesh agent's letting him go crazy, I guess. I don't know what's happening. Did I do the right one? Update rotation equals true. Yeah. Oh, another thing. Nav mesh agents basically said, yeah, you just had to turn this way. But rigid body's like, oh, but you have all this force turning you around. So in order for it to look like the nav mesh agent's controlling it, you also need to go to the rigid body and freeze the Y rotation, because now physics is not handling the Y rotation, it's the nav mesh agent. So if you freeze that and then hit play, nav mesh agent will take over rotation, because we're not modifying rotation at all through the physics. But then if I uncheck Y again, physics now has control, and if I hit something at a weird angle, I think he'll start rotating a weird way. I don't know, but it's fortunate that I hit, oh, there we go. I kind of slide off that box and you can see I'm rotating like crazy. But nav mesh agent's like, no, you should really be still. So, you know, it's kind of conflicting. So, okay, lock the Y. Now nav mesh agent has taken it over, and it's all great. It's all gravy, baby. Alright, so now you understand nav mesh, you understand rigid body. And we're only 23 minutes in, so it really did take a long time already to explain all that. Okay, last but definitely not least, the animation. Go to player. I'm gonna disable some stuff. Okay, freeze that Y. Remember, I was in play mode when I was playing that, so I gotta do it when I'm outside of play mode. Nav mesh agent looks good. Yep, that all looks great. So we have our nav mesh agent. I'm going to put in just a model. So this is a model directly created in like 3D Studio Max or a 3D modeling package. So we're going to grab the one built in with Unity on the third person. So I think if I go to third person, models, we have this Ethan model. Let's see if I double click it. Yep, that's not what I wanted to do. But anyway, that's the model right there. I don't know if you see it. You don't, because it loaded up in a different window. Alright, well, anyway, I'm going to drag this Ethan model to the scene, because I don't even see the preview. Put it right here, and make sure it's at 0, 0, 0. I'm going to double click him just to zoom right up into the area. So there we go. This is a built-in Unity model, Ethan. Put it in perspective mode. Ethan again, there we go. So his pivot point's by his right here at the center between his shoes, and that's where I guess most like 3D models like to have their pivot point. Oh, brother said hi. I will say hi back. Hey bro, thanks. Cool. Alright, so we have this 3D guy, and we want to apply a little animation to him. So what we can do is, and really what I'm going to show you here is that the animation has like motion built right into it. So in a 3D package, someone built a model moving forward. So if I look at some of these, I'm going to disable my face right quick. Where's my face? Is that my face? It's gone. Good. So if I look at humanoid run, really a walk would be better so you can kind of get the effect. Okay, so at the bottom right you can see that there's an animation, and it's kind of default Unity, even more default Unity humanoid model. If you hit play, you see there's a walking animation, and what tells you that this is a walking animation with motion in it, besides looking like at all the stuff up here, is that you can see that the pattern, the floor is actually moving with him as he walks. So here's the actual animation information. And we'll get more into this if I make a 3D model and we actually try to put it in here. But for now, this is the animation information. So this is a clip of humanoid walk. It's in this little time segment of the entire animation. So it's a loopable animation. And here we go. Here are some things we'll talk about later, but this is the gold right here. The average velocity and the average angular y speed. So these are the two values that really tell you what's happening here. So he's moving forward at 1.5 units straight every second. So that's the average velocity per second. And then he is turning this. So typically we like to have maybe the turning, if you're just walking forward, at 0, and the velocity to not have any kind of X component or anything if you're just talking about a straight on forward movement. So this one could be tweaked a little bit using some of these options up here. But for now we'll just leave it as is. He'll kind of walk off the line a little bit because there is a little rotation and shift in velocity. But okay, so what we're going to do is we're going to take this animation, drag it on Ethan. And was that right? I think I lied. Delete that. Don't listen to what I'm saying. And now start listening again. If you go to humanoid walk, under there's a humanoid walk animation. That was like the whole model with the bones and everything. Under there's the actual animation. You can apply that straight to the Ethan model. So if you go right here, boom. So now if I click on Ethan, he has an animation controller, and he has apply root motion, which is the most important part. And so if I hit play, besides my nav mesh agent, we'll see that Ethan should start walking, and you'll see he walks. Oh, he's walking away. I should have turned him around. But you can see he's just walking with the built-in motion, but he has no physics. The only thing controlling him is the animation. There's no motion via nav mesh. There's no motion via rigid body. There we go. So he looks cool, walking on air, walking away from the scene. So anyway, so nav mesh agent, Ethan. Why did I say nav mesh agent? Animating controller motion. So yeah, and you notice that, like, I'll play it one more time. His steps are exactly as the animator anticipated. Like, he is walking at the velocity, like, it's perfect. Like, his legs are going down, hitting the ground, no sliding of his feet or anything. So yeah, that looks great. So that is the third third movement engine in Unity. And somehow, if we're gonna make a top-down game that you can click around, get him to move wherever you want, and looks natural, and can like interact with other physical objects, you need all three of those components working together, and you got to know what takes over the velocity and acceleration and force at what times. So that's where it gets all complicated, and that's why I've spent maybe the last episode and this episode talking about these three components, because if you get an understanding of the base, I feel like we can make something that feels natural, looks natural, and like looks really good. So okay, I'm gonna delete the Ethan model. So now we're gonna go back to player model. So the reason that I've made like player its own object and then nested like the two shapes is if we really wanted to, we can put Ethan into the player model, and we can put whatever character we want under the player model so that his visuals are kind of not attached to his actual logic. So he can still walk around, do whatever he wants, and then he can like say, oh, I don't like that model, I want to change him to look like something else. You delete the models under it and then put the Ethan model or whatever model under here, and you'll have a whole different character, but with the same logic that you've worked so hard on before. So okay, so I'm going to do just that. I deleted the capsule and the visor, and I'm going to grab the model of Ethan, and yeah, I'll grab this whole thing. Okay, so I did the model, and I'm going to drag him under player. So you got to wait till it's highlighted, and then you let it go, and bam, now he is a child of player. But player starts up there, but if I let him play, he just falls. And like, look, the animator controller and nothing's set up, so he'll act the same way that the other one was doing, but he might not look at all what you expect him to be doing. But he's at, like, it's not bad, right? Like, most of your logic is still there, even though you didn't do a darn thing except just delete stuff and drag the other model into it. So okay, let's fix a little bit of that up. Let's go to player. We can see, oh yeah, he's way above the capsule. So that's all to do with the center, right? Or do I move Ethan? I always forget. I really don't like messing with player settings when just adding a model, so I'm going to mess with Ethan. So if I move him down one, yeah, that looks better. So he's going to have a little buffer on his head, but I don't really feel like, okay, yeah, we'll go ahead and mess with it. So instead of 1.2, let's try 1.5. Yeah, that looks good. Then we got to move Ethan again. So maybe I shouldn't move Ethan. Alright, we'll leave Ethan at 0, 0, 0, 0. Makes sense. We'll just mess with this capsule collider. I don't like doing that because we also have the nav mesh agent. Yeah, like, you see, I really don't like messing with this player settings. So back to it. 2. Move Ethan down to -1. Yep. And so now he's at the bottom of the both things. But if we really wanted to shrink some other stuff, we go like 0.5. No, 1.5. So that's him minus some hair maybe. And let's also do this to be 1.5, the capsule collider. But then we'd have to move this down. So if we shrunk it by 0.5, we move it down by like half of that. So -2.5. So there we go. So now if I play this, he should fall like he normally would. And then he like, there's no animation, but at least he's moving towards where he needs to go. Cool. I hope you guys are seeing that. Good, not much dropped frames. Nice, nice. Okay, so what is next? Alright, so let's get him to animate it while he's moving around, because he has this cool movement, but he's not moving. He's just kind of gliding to his next location. And we really did this the hacky way, where we're just changing the velocity. So we should really change that up too. Okay, but before we do, let's just take a look at our code. Alright. Well, first things first, I kind of like to break things in functions. Like, I don't like it have an update function and just have like a zillion lines of codes in it. I want you to look at, hey, look, this is the update function. It's doing this piece of code, it's doing this piece of code, and doing this piece of code. And then you can drill down to see exactly what that piece of code means. So like for this one, I'm just going to select this piece of code. I'm going to say refactor. Oh man, you can't see it here either. I got to do the same thing I did with Unity. Just captured a monitor, so I'm gonna click a button on the side here. Oh, it actually won't work anyway. Let me just disable the plugin then. how do I disable plugins in this broadcast thing? And screen switcher, stop running this plugin for now. Okay, and then I'll just click on Unity, and it might not be as good because the windows don't move around, but you know what, it's okay. So what I'm going to do is I'm going to select this code, refactor it. So I'm extracting the method, Control R, Control M, or I think it's under Edit, Refactor, Extract Methods. And we're just going to call this detect click. And if you really want to like make it lengthy, and set motion or set destination, something like that. So a really long name, but at least you know, hey, that's what it's doing. So you don't have to read the code under it. You got like a nice function that just kind of says exactly what it's doing. Okay, what's next? What's next? So this part is not detect. It is rigid body movement via nav mesh agent. Yeah, I really like my long function names. So if I look at the update function, instead of seeing a whole bunch of lines of code, now I just see two different things: detect click and set destination. Rigid body movement via nav mesh agent. Yeah, I don't know what's really the best coding practice, but that's kind of how I like to do it. Like I like to see the top general idea of what I'm doing first, and then you kind of work your way in. But you know, I like working in the update function and then just extracting the method once I'm done with that like logical thought. So okay, so right now I'm just doing it the very hacky way. We're putting the nav mesh agent exactly where the game object is, so that's going to continue as is. That doesn't need any modification, but this whole rigid body velocity equal something else is not exactly how rigid body likes to work. Rigid body likes to use this add force method, and what the add force method has is like a force, and like if we really just were lazy and just didn't feel like doing anything else, not checking for maximum force or anything like that, we could just put that vector in here and say force mode dot velocity change. And what that would do is it would use the actual add force method to add the right amount of force. Instead of just changing the velocity, you'd be actually adding a physical force, but there's no cap to it. So if I just did this, he would be able to move through anything. And maybe I can show it this time, unlike last time where it made me a liar. This one I might be able to show you. So I save the script, hit play. So right now if I move, oh my gosh, he launches away. What's happening? His Y is okay. Oh, this is the change in velocity. So that is something different than the actual velocity. So the change in velocity would be this. And that's why I'm not used to seeing this like rigid body velocity dot y, because usually the change in velocity would be 0. So we usually don't apply any force up or down. We let gravity handle it. So okay. Hey, my face is gone. I'll put it back. So okay, sorry. Rigid body. First we need to change in velocity. So we'll do, that's another vector 3. I call it d velocity or delta velocity. Change in velocity. And so right now, rigid body is always going at a current speed somewhere. So we'll get what rigid body is doing, whatever rigid body does, whether there's a collision that hit him or whatever. And then we're going to subtract whatever rigid body is doing to us right now minus what nav mesh agent really wants us to do. Nav mesh agent dot velocity. And so that's the change in velocity, right? So if I'm like getting pushed all the way to the left, but nav mesh agent wants me to go to the right, I'm going to try my hardest to go to the right. So that's the change in velocity. But this is what I also like to do here. Delta velocity dot y equals 0. I don't want nav mesh agent to tell me how I move up and down. That is not nav mesh's job. It's rigid body's job, and maybe even the animator controller's job, but not nav mesh agent. So we have delta velocity equals y equals 0. Okay, cool. So instead of what I did here, which totally screwed up everything, we just put in delta velocity. So like I was saying, if you're lazy, you just want to apply an infinite force to make your velocity be exactly what it needs to be at that time. This is the way you do it. Or heck, just make the velocity equal to what you want it to be. But this is a little bit more formal and better way to do it, to kind of protect against any kind of future updates or anything. Because what if they make velocity no longer an accessible variable, but they do keep the method add force, which they will, because that is like the bread and butter of this. So if velocity is no longer accessible, you won't be able to hard code the velocity right into it, and then you'd have to end up doing this code anyway. So I don't know. You might totally disagree with me, which is fine. But using the functions, there's a reason they made the function, so use their functions as opposed to setting variables hard. Yes. Program philosophy. Should be like a course, right? Probably is a course. So if hit play, hopefully this guy does what I ask him to do. No, why does he fly off the screen? Let's figure it out. So we have the change in velocity. Rigid body is doing something. Nav mesh is doing something. The y is not doing anything. And I'm just saying, hey, change the velocity from what you're actually doing to what you should be doing. Yeah, that seems fine. What am I doing wrong? I saved it? I guess I did, yeah. What if I like click right next to him? Oh, I can't do it. Choom! And he's out of here. I don't know. I don't know what I messed up. I'll figure it out. Let's see, anyone on here? Oh, nice. Hi, viewers. If you don't see what if I'm missing something, let me know. Alright, well, let's just look at the script one more time. So, okay, detecting the click, that's fine. Rigid body movement via navigation, nav mesh. So maybe I'll set the position after all this delta velocity stuff. Maybe that's a problem, because maybe me shifting something somehow makes the velocity wrong. Nav mesh agent dot velocity. Yeah, I don't know. Delta velocity. You're just adding the change in velocity, right? The change of velocity is this minus that. I wonder. You know what? I might have to multiply delta time, because this is the velocities per second, right? And this is, I'm changing the velocity like in a fraction of a second. So this is running one every 30 frames, 30 times every frame, which means that if I apply like a certain amount of velocity 30 times within that second, he's going to be moving a lot faster than if I would have just said, hey, give me the velocity he should have changed in just that change of a second. So that's what I'm going to do. Oh, and another thing is a more important thing, which I'm going to bring up in a second. I promise. Time.delta time. Okay. So now we have the velocity change in just that like what, 33 milliseconds or something like that in just a little piece of time. So if anything, he'll move super slow, but I think he'll move at the right speed. I think that's what the problem was. Nope, he's moving super slow. So even that is wrong. Alright, the other thing I wanted to mention is this should be running at a fixed update. All the physics runs at like certain time steps, so it doesn't actually run as fast as your update, because it has a tons of calculations to do. So instead of update, you should make this fixed update, because the physics engines, and especially rigid bodies, only really like to work in this function. So that's an important thought, but not what's going on here. Goodness, I have no idea. I feel like it's so easy. Something so easy. Oh, and the other thing is, I think I know. He's flying the opposite direction that I'm clicking. So maybe it's just my understanding of the whole thing. Eureka! It works! Okay, so. Uh-oh. It worked until it didn't want to work anymore. So it's working. He can move around, he can rotate. Let me just look in the top right quick. And let's see if we can just get ground, just so we can kind of see the whole level. So we can see, if I click around, he's pushing stuff around, and he does it at his own will. Okay, great. So we're using the add function, the add force method, which is exactly what I wanted to do. 46 minutes in. We talked about. Let me pop up my notepad right quick. We talked about animation movements. We talked about rigid body movements. We're trying to put it all together. I mean, we're having a hard time just putting nav mesh and rigid body together, but I'm going to do that. And then next time we'll try getting animation in it, and then we can start talking about camera movement, and then what the other. So if we can get movement feeling really good, the other thing I really want to do is get that that camera going from third person down to like first person, looking on the ground, working very well. Those are my two like main core mechanics, I guess, of the game that I really want to just feel right and look right, and everything else can just build on from there. Like, I want those two things to work impeccably well. Alright. So back to it, back to the grind. So yeah, it was a matter of me figuring out which velocity to subtract from which velocity, which can be a killer thing sometimes. So yes, observe which way your guy flies when you click, if he flies somewhere. Okay, onwards. What do we want to do? What do we want to do? What do we want to do? We have the change of velocity. Then, yeah, I don't know which way this should be. I should look in the Unity documentations about that. So I'll just put it at the top, run it again, see if that works. Yeah, looks good. I'm getting kind of weird, like some clicks aren't registering or something. I don't know. Yeah, like that. I just clicked it. Nothing's happening. I don't know if he's supposed to be trying to move, but then the second I click again, he moves. Oh, I think I know what's happening. And you guys are going to think I'm crazy, and I hope you do. But look, when you're detecting a click, that really shouldn't be handled in the fix update loop. That should just be handled in the update loop. But when you're doing anything with physics, that should be handled in the fixed update loop. So there's two update loops. Regular update loop that runs as fast as it can. So if you have like a game running at 120 frames per second, I'll try to run it at 120 frames per second. Sometimes it can't, so it'll like skip a jitter a few frames, and so you're going to use like the time delta time function if there's something that you need to calculate for that fraction of a second or however long it took to run that loop. And then there's the fix update, which runs very like this interval, bop, 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 bop. Slower, typically slower than the actual gameplay. And that one you'd use time.fix delta time to do your calculations with those. So just keep in mind what loop you're in, and remember to use the right functions accordingly. So okay, maybe that will fix my weird clicking issue. Like I said, I want this to run impeccably well. So one misclick and it not running exactly how I want it to do it, I'm gonna debug that sucker. So yeah, I feel like this is exactly what I want. It's not hanging up on me. Yes, this feels good so far. Alright, the other thing I kind of like to do, and I know he's rotating, but that's okay. That's what the navmesh agent wants to do. I think it's because like gravity is kind of making them move at a certain way, and so like at some point you just gotta say, hey, if you're at your destination, stop rotating. So that's some code we're gonna add in later. Yeah, that looks good. Oh, so why do I keep saying that this is like the lazy way to do it? Alright, so if I click here, we can see we easily move the box. If we click on that box, whichever box that may be, yeah, that one, I can see that's highlighted right there. If I give it a mass of 20, click here, man, I am just not, it's maybe I just don't understand something about this, but he can't push it because he's trying to go forward. His force is saying, yeah, if you want to move forward, just apply X velocity this way, but something's capping it, and I don't know what. Maybe nothing. So okay, he can't push it now, and he's still trying. I know there's no animation to really show that, but he's still trying to walk through the block. So as I move that mass up, you can see he gets up. He gets up there eventually, and he's able to push this box again. So he's applying, I still think he's applying way too much force. Like there's no way this 3 or 4 kilogram object can apply a force to move a 20 kilogram object. And just so I can exaggerate the numbers just a little bit, I'll get number 2 again. 200. So okay, there's no way he can move a 200 kilogram object, and he can't. But I still think it's cute a little bit. So if I move this up, we're gonna we'll find it. I'm just slowly lifting the mass up. Bam, like I'm 20 kilograms. There's no way I should be pushing around a 200 kilogram object. No way. So we have to limit the force he can use, is what I'm trying to say. You want to have a realistic force. This force is not realistic. I hope you agree, because that's why I'm like very much into this whole like combining the 3 movement engines and using like the right formulas for everything, because I want it to have a very good feel, and I want every system to work as it intended, you know. Like it looks okay, it runs okay now, like I don't really have to do anything here, but if I really want the physics to work as intended, I need to do a little more work. And that's what I will do. 53 minutes. I might run a little long today, just because I really want to get some good foothold established in this. Alright, so, oh good, you saw my sweaty armpits. So what's next? Animation, of course, animation. So how are we going to do animation? Right now he's not animated. So things we can do. I know earlier, last episode, I showed the animation controller on a 2D Cartesian plane. I'm going to steal that. So if I go to Animator, there's a third person animator controller. If I look at it, I guess I really can't look at it here, but I'm going to drag it onto player. Oh, and look, I'm in play mode, so whatever I'm doing now doesn't really count. So I'm going to undo all of that. Player's here. Third person animation controller. I'm going to put it on player just because. What's the reason? Kind of the same reason I have Ethan as a sub object under player. Like, the animator controller has a big part to do with the movement, so I figure all logic, including animation logic, should be done on player, not necessarily on the sub objects, which is just kind of the display. So now under player I could have Ethan, I can have sunglasses, I can have hat, I can have gloves and gun, and that way all these objects under player don't necessarily need to know the logic what player is doing, but can act individually, but still move around with player and get, if like he gets hit by a big bus or something, he can fly across the screen with all his objects intact, as opposed to like having separate objects, or if I had Ethan as kind of the root object, and I decided I didn't like how the Ethan model looked, I'd have to like unparent all these children and then parent. So having a game object as your like root, kind of like an empty game object as your root object, I think is a great idea. That way you can put different other objects inside of it and switch them out and just keep everything very modular. Yeah, so that they're not very like reliant on each other. They're just reliant on this empty game object, which is kind of an abstract idea, but it's still, I don't know, I'm blabbing. Let's keep going. Here we go. So we added the animator third person controller, and it's just asking for an avatar. So if I click on here, we will see that the Ethan avatar is one of them. I believe that's all I do, and I'm going to apply root motion. No, I'm not going to do that now. Basically right now what's controlling the motion is rigid body, and that's being controlled by nav mesh. I'll just keep saying that until it sinks in my own head. Alright, cool. So if I look at the animation controller by double clicking it, it is this blend tree. So luckily Unity did this all for us. I could go into making all of this too, because I watched tutorials and I kind of understand what's going on here. In the animator we have these variables. Right now I'm not too worried about crouch, on ground, jump, or jump leg, so just ignore those excuse me, for now. But we do want to worry about forward and turn, and actually right now I'm only going to worry about forward. Turn we'll add a little later. So I just want Ethan to look like he's walking or running depending on how fast he's moving forward. So how do we do that? Well, we have to modify these two variables. So if I go into ground it, oh well, just because I know this animation, but I'll explain it out right quick. These are the three states Ethan can be in. He could be grounded, he could be airborne, or he could be crouching. The only way he can, oh, and he starts off on grounded state, so that basically means he's on the ground standing. The only way he can get to either of these two states are through these transitions. So if I click on one of these transitions, we'll see, hey, the only way I can go from here, from grounded to airborne, is if on grounded equals false. Right now on ground equals true, and I have no intention of changing that right now, so it will always stay on this grounded state, so it'll never go up here. And if you really want to know if you're airborne and to get back to the grounded state, you have to be on the ground, and your jump factor, which I don't know what that is yet, is -2. So I haven't really paid attention to any of that. So okay. The other way, if you're in your grounded state and you want to go to crouching, the only way that can happen is if crouch equals true. Right now crouch is equal to false, and like I said, I have no intention of changing that right now. So that animation won't play either. Let's see. Yeah. I don't know why he's so sunk in, but I won't worry about it right now. I think he's so sunk in is because I moved, instead of moving player object around, I moved the Ethan object around. So, and I don't know if that was a good practice. I think it is. But just one last, the reason he sunk down in the ground. Oh, you can't see. I have to mind you guys. He's look, Ethan down here, he's sunk in the ground. So I am going to show you why I think that's the case. Player right now is here. Ethan is -1 down. Because Ethan is -1 down, his preview is showing -1 down. That is the center right here. This empty game object uses the center. Ethan uses this as the pivot point. So game object, players, this is the center. Ethan, game object, or model object, is using this as the pivot. Maybe I should match them, and I think I will. So I apologize for doing this again, but it just, I go back and forth, and this is kind of the iterative process. You know, you just kind of got to do it. If it doesn't feel right, doesn't look right, something's wrong, you fix it, right? Okay, so here we go. What am I doing? I'm moving Ethan up to 0, 0, 0, where you intend it to be. Player now needs to, instead of 0, let's make this like 0.25. How about 1? Too high. I'm just guessing now because I really don't know right now. 0.5. 0.75. Perfect. 0.75. Same thing with our nav mesh agent. Base offsets 0. Oh, perfect. So no base offset and 0.75 offset for our capsule collider. So if we look around, perfect. So pivot point is now between the shoes for everything, for player, for Ethan, for everything. And I think that's how default models are built. Like everyone likes the pivot point at the center bottom of the player's shoes, or like where he's walking. I mean, that's how the animator likes it, at least, so I'm going to abide by that, if anything. Alright, back to the animator. So if I go down here, click on here, animator, click on ground it, click on these transitions. Oh yeah. So now you can see he's obviously on the ground exactly where he needs to be. So if I double click on ground it, if you remember from last video, these are all the different states. He's idle here, he's running forward here, he's running at like a 180-degree angle here, he's turning at a 180-degree angle here. I can show you the demo right quick. This is him at idle. If I drag this little thing around here, you can see he's just turning 180. Oh my gosh, he looks like a fish. What's he doing? Okay, maybe I need to look into this a little more. Player. Avatar. Maybe I'm not supposed to be using that avatar. Maybe I'm supposed to be using the human something avatar. I don't think so. I think I'm probably just screwing it up more now. I don't even know what's happening. Okay, don't do what I just did there. Okay, let's use the ETH. Oh no, I double clicked it and now something's happening and I don't want that to happen. Okay, Ethan avatar. Here we go. Anyway, what I'm trying to show is right now he's in the idle animation pose. And I know that spinning is due to some weird nav mesh rigid body glitch. Really, rigid body is like kind of moving him away from where the nav mesh wants to be, and nav mesh is like, you know what? You're not exactly on the point. Even if you're 0.00000000001 off, I'm still gonna try to move over there. So that's why he keeps like spinning a little bit. So if I made the stopping distance here like 0.1, which you can't see, I'm sorry. Gosh, I hope. Yeah, that thing was probably on there a long time. So you haven't been seeing all the stuff I've been doing on the right hand side, so I'm sorry. So I changed the stopping distance to 0.1, and hopefully that kind of like stops him from spinning too much. Maybe a little more, 0.5. Yeah, rotation's constrained. I don't know. Okay, I'm over an hour, so let's start wrapping this up a little bit instead of me looking everywhere. So what am I doing? Oh, yeah, the animations. So we just want them animated. We don't really care right now about all the other stuff I was talking about earlier, like his foot sliding or anything. We'll worry about that later when we're like tweaking the movement script. But right now his animation is playing, but he's just playing the idle animation because we're not updating any of these two variables. So we're going to do that via script. So we're going to open up a Visual Studio. Now we need access to the animator, and I do those underscores under the before the variables just because I like to know what my private variables are and what my local / public variables are. So that's one easy way for me to figure all that out. Animator. Cool. So we have access to the animator, and the only thing I really want to do is animator dot speed. No, that's wrong. The forward variable, but you can't just access it by dot forward. You need to like set float. We'll call it forward, because you can see one of them is string, name, and float value. Of course, strings are more expensive than ints, so if you know all the directions beforehand, it's probably better just to specify them in the start function, like get the int of this forward and just reference the int instead of the string. But I am lazy and I will do it this way for now. And all we need now is the rigid body velocity dot magnitude. Yeah. So now all this is doing is saying, hey, if your rigid body is moving, set the forward variable in the animator to that same thing, and just do that every time you update. So if I do that, hit play, we can just watch this forward variable. And you know what? I have Y happening, so the second he fell, you saw that Y move. But okay, now he's moving at 3.4, he's kind of running there, then he stops. But you can obviously see his feet are sliding like mad. But not too bad, right? Not too bad for a start. We got a guy moving around in an hour on a 3D plane, which is pretty impressive. Also, just because I hate clicking so many times, where I have input get button down, if you just say input get button, it will check whether it's down or whether you're holding it down. So I can, at this point, as long as I'm holding it down, it'll always set the destination to where my mouse is. So I took out the down part, just checking if it's being held down or being pressed. Now I just hold it down and he'll just move to wherever my mouse is, which I kind of like that feel. Like that feels a little better. He doesn't look better running there, but it feels a lot better. But yeah, he can't jump or do anything yet. But he does reach his destination and then stops, and he goes back to the idle animation, which is awesome. Like, I love the animator in this thing. So okay, now that I am officially like 8 minutes over, I have a final tomorrow too, so I have to study for that. So yeah, that's what I'll be doing the rest of the night, minus eating and relaxing a little bit too. Yeah, you can see this forward variable right here. It's like kind of going crazy. Just because I'm not sure if that's the nav mesh agent or the rigid body, like kind of like trying to move the object a little bit. But we'll visit that later. So okay, I think we did pretty good with animation movements, pretty good with rigid body movements. We're like halfway through putting it all together. So all in all, I think my topics were on point. Next time we will put it all together, try to get to camera movement, and this will have to be our stretch / next time topics. Next, and this will be this time topics, or better yet, topics. Okay, so we're gonna put it all together, do some camera movement, And then the next time or the time after, we'll figure out how to switch from that third person top-down view straight to a first-person view. And I think that will be very good. And just so I'm telling you guys, I've worked on this movement engine before I started to stream because I just wanted to be confident in something that I know how to do. But starting with the camera movement down to the rest of the topics I haven't touched, so my knowledge on that subject is going to be a lot less. So it'll be more of an exploratory journey where you'll be joining me as opposed to me kind of lecturing what I kind of know already, but also kind of figuring out already too. But yeah, I just really want to go over this movement thing again because I really want to make sure it works. And I just want it to feel right. And him falling down and running is not feeling right. But we'll get there. We'll get there. So I'm definitely not going to let the nav mesh agent control the rotation. It just feels too unnatural. Like if I wanted the nav mesh agent, and I'm in play mode, so none of this is permanent. If I wanted to look a little better, I could like do a 360 angular speed, so like he turns around a little better. Like, yeah. He doesn't like run backwards for a little while and then turn around like, yeah, I'm going the right way. So it looks a little better if you up the turnaround speed, but not that much better yet. And oh yeah, this rigid body thing that drives me crazy. I don't want him to be able to push 200 gram blocks if he's only 20 grams, or you know, add kilo into each in front of each of those. Cool. Yeah, gosh, the other hard parts I find is just stopping because I want to keep going. I just want to go all night. I could program all night long. Okay. I'll be posting this on YouTube using the Twitch export function. And yeah, that should be it. I'll fix this Visual Studio so that I'm using the Windows capture because I really want you guys to see, like if I type in time.delta time, I wanted to see it on the stream as well. Like I just don't want it to only for me to see. Like this is for both of us to learn, right? Like I'm learning, you're learning. Yeah. So, okay. More later. Bye everybody.